Welcome back. Today we are going to get into programming. Today we are going to get into the code that goes inside of your objects, and we'll review. And I was just saying that here's something that I did last night. I was just messing around, and it's very simple in that it's just a light that I've put into a blueprint and then set up an animation on it so that it just moves forward and backward through the physical objects that are in the realm. So this is just happening. There's nothing, I'm not changing the materials, I'm not lighting anything up, it's just moving back and forth, up and down this tube, right? And I'll look, today I want to look a little bit more at the things that the controls can do with the Dynamandala and stuff like that as we explore the way that arrays are used and other data points that I'm doing with this. So we'll look at this stuff a little bit more. I just thought this came out really well. It's got a really nice, slow gradation to it. And I can just sit here and mess with, if we look at this, now I have the, so this is what it is right here, is it's just this object, right? This is one of the Dynamandalas and the way it can be. And this is the BP point light. And it is just literally moving. Well, I grabbed the wrong variable here. Let's do this one. It's just moving up. You can see it a little bit. Actually, if I turn the light, the directional light back down a little bit, it'll even be more apparent. So it makes sense, huh? I'm really into the idea of this kind of, one of my big inspirations actually, when I was thinking about doing this project, I was at Disneyland, and in Mr. Toad's Wild Ride, right in the front, they just have this big plywood, barrier, and it's got these slots cut in it, though, that are kind of spiral, and they're holes through, and then they just have a big disc on the back of that that's got spiral painting on it going in the opposite direction. And then you just spin that thing, and you get these cool radiating patterns going out through, the apparent grooves. So, again, I think that's fun. That's interesting to me, the mechanism of building it, the whole idea, and I think that that's very much the kind of thinking that you can bring to the computer here. Again, I really want to emphasize the idea of the computer is not really being, mystical. It's very physical. It's just as if you had a bunch of paint and everything to build things with. So let me change a few settings here for the purpose of us to. So what I'm doing is there is just this blueprint where I added a point light in, and then in the event graph, I have something called a timeline. And we'll look at this a little bit more, but a timeline is a small animation engine that you can put inside of your blueprints. Many of the, there's always forward-moving time in the game, and they'll call that tick, as we talked about the other day, and oftentimes people can use that to drive animation forward, but the problem with that is it's always happening, right? So no matter where you are in the world, as long as it exists in the world, it's going to be ticking away and using up resources. This is a graph. Can you see it very clearly? It's a little hard. It's just basically a simple sine wave going up and coming back down again. And also notice that this is going from, this is at time 0, it's at 0. At time 5, it's at 1. And at time 1, it's at 0 again. This is a 1 second duration variation from 0 to 1. There's many, you can do other kinds of tracks in here. You can make a multi-curve track and things like that to be able to do animation curves. This is an animation curve like you might be experienced with in any 3D app. But we're looking inside it right now. When I look in the event graph, this is what it looks like as a node in the event graph. I'm just jumping forward in this because you asked. And I've got on this, actually, if I open it up, I've got loop and autoplay turned on. So it's a very simple way to create an oscillator. Again, as I said, it's 1 second in duration, and one unit in value. And this has to do with the concept we talked about yesterday of normalization. So that what I do with this then after it comes out is I actually use that 0 to 1 value as the driver for LERP, a linear interpolation. Remember we saw that yesterday when we were looking at the way that the material was broken up between the black and the white sections and allowed to be affected separately. So you'll see these similar kinds of nodes in many places. Anything that works, they're going to use everywhere that they can. And a LERP is a linear interpolation, which means it's a phase between two values based upon a third value, which is an alpha channel. So this is a form of conditional. We hear about conditionals today. And all that I'm doing, if you see here, this says set relative location of my point light component. See how there is light range as a variable. It's just a float. It's set to 300 by default. And I am sending it through a multiply times -1. So that basically I can set a value of 300, and now it'll go from 300 to -300. So the value is going from 0 to 1, beginning to end, and back to beginning again. But what the 0 to 1 is variable depending upon what I want to set. So the idea of this is that 0 to 1 value can be fed to anything else and amplified beyond that to the range that you need. But I could have another going left to right and say I wanted that one to go 1,000 overall, right? I could set up the same code for that one but make its light level be 1,000, but I could use a single timeline to run both of those. Okay, so let me just change over to class material, SETI day 2. I am not giving you a file today because you're going to build this yourself. So here is something we're going to build, and they're going to use this to look at a lot of the different parts of what goes into, or the different elements that we have with coding. Just a little preview of this. If I start this up, let me make I can take this here and go into the details panel, and I can set how far apart these things are, if they're on top of each other, if they go the other way. I can set how many of these there are. And I can also set these values here, which will make more sense in a second. So if I look at this and now I have a key that I can control it, they jump up, but when they jump down, they all turn random colors. When they jump up again, they all go random places. So let me back up my start position so we can see it all a little bit better. I can just push this thing back. This is creative coding. In my mind, I just started messing around with what I might do with an event and some variables that I could change. And you'll be able to customize this. So they randomize what their height will be when they jump up, and they randomize their color when they land, and we're going to understand. See how there's one in the front that's doing the same thing as that, but not necessarily exactly the same? Ultimately, that's what we're going to use. And I will show you how it all fits together now. Here we go. All right, everybody up and running, ready to go? Cool. Okay, just want your engine open and follow along as we go. We'll be building some stuff in the engine. I think it should be pretty straightforward. So yesterday, I just want to go over what we talked about yesterday quickly to review to make sure we've got it all fresh in our heads. We went over the Unreal Engine. We went over placing things in space and how there's an X, Y, Z coordinate for those positions in space. We went over lighting the space so that we can see things in the world. We went over manipulating the color and surface appearance of the meshes through materials, which are the small programs that we write that control how the light reacts to the surface, really. Then we were working with a node graph editor inside the material editor to build these materials, and that gave us an exposure to node graph programming and the idea of a flow and all that kind of stuff. And we also looked at the way that we can instance a material to create a copy in which we can customize various parameters that we build into the structure of the material, knowing that when we instance it, it will mean that those are things that we can talk to via code or as user adjustable variables in the editor, right? Everybody good with that? All right, so then we also talked about actors or objects or blueprints, basically, and the fact that they have data and functionality inside of them, that they are the key of interactive things we build in the world. That data is something, a 3D mesh, an animation, a location, a size, a duration, a color, a speed. They are things, a data table, there's other things that we haven't talked about so much, timeline, there's other pieces of data that can be in there. And I want to say that, we briefly were looking at the timeline that was going up and down. That's just a float variable with some special code wrapped around it to manipulate that float under familiar controls of play and pause and set speed and make it go reverse and has it stopped, has it not stopped, and all those other kind of things. But ultimately, it's just making you a float that you can apply to other things, just like the 3 floats that sit in RGB, just like the 3 floats that sit in XYZ, and are being used to control other things. But it's a float, it's a decimal point. It just means that you have the ability to go between, individual integer steps. So seeing the creative recontextualizing of the variables for different effects is a big part of understanding programming, and also lowering the idea that there's a billion things to know. It's really just there's a lot of ways to use floats, but if you know what floats are, you can follow the logic of using it in various ways.
Can you explain float again?
A decimal point number. It's a value. It's an integer value that is a number that has a decimal point. So it's not just 0, 1, 2, 3, 4, which are integer numbers. Integer numbers are generally used for counting. We'll see that when we look at for loops and arrays today. They'll become very apparent there. Integers and floats being different things really has history in, bless you, in the limited space of data paths that existed in early computers. And they needed to say, if I'm going to have a float and I want it to have this many places, how many, there's a byte of information is 8 bits, 801 binary numbers. You can make 256 values of that. Sending byte, things is easy to do in one thing. Computers are optimized for that. You hear things about 32-bit, 64-bit, all these other things. These are other architectural things within the computer that say, I can quickly transfer a 32-bit number. I've got that big of a path. I don't have to break it down into individual digits and then reassemble it somewhere else. So a lot of standards and ways that we work in computers really have to do with the machine functioning well, not because bytes are special or anything like that. So float and integer being different, the idea of typing between them and two, is largely a vestige of old computer technology, I say, as not a computer historian, so people can shoot me down here. But there's a lot of languages now that we'll talk about, and I've seen this a bit, the fact that you don't have to type variables. You can just put, you don't have to declare that this variable is a float or this variable is an integer. You just put a number up there, and it's more fluid, and it just gets rid of some of those old vestiges. I can't remember what language it was that talked about that. But again, the physical practicality of what we are doing is what I'm trying to emphasize. We're working with this gizmo machine that has certain pathways and certain capabilities, and it's not magic. It's not mystical. It's hardware, and it's mechanical. And both our code and the machine are like that. And the more that we can be in contact with that, the more that I'm able to remember details of things and know what I'm talking about, at least enough for me to function. So that's a big one for me, and that's why I speak of it so much when I'm talking to you. So we talked about objects and actors and blueprints, which are all the same thing. They are entities, and it's a way of structuring our code so that we have interactive objects in the world, things that we can know where they're at and what we want to do with them functionality-wise, and it's just easier to keep track of. We could tell things, no, never mind, rabbit hole. Okay, we also talked about what is programming. Now, this is a slide I had earlier, but I changed a little bit about it because I want to be more specific about now getting into our objects. Programming is creating our functionality. Remember, we have data and functionality, and we talked about the idea of an object that was a vehicle, let's say, and your base vehicle object may have go forward, go backwards, go left, go right, go up, go down as logic that's in there. Maybe up and down wouldn't actually be in there, because if you're going to make a vehicle and you're going to have it be a car and you're going to have it a boat, neither of those go up and down, so it's forward and left and right. And Blueprint is really used throughout the entire program. It's not just for making these actors, excuse me. So anything that you put, a Blueprint could be data only and other things that have to do with the ability to manage information as you're making a game. So there's a little bit broader definition of actor that we could technically make, but for our purposes. Yeah, for our purposes. And the biggest thing about that is I got so sick and tired of people saying class on videos. I got a class here that I'm going to do this class with this class, and I just was like, wait, what's that? And when I realized it was an actor, that's why I say this over and over again, right? Because this is about these terms that can either be barriers or keys for us. And so I'm here to try and tell you these few terms that were the ones that really opened the door for me and made me stop being confused, right? Dope, okay. So what is programming? Programming is creating our functionality inside the actor. We've built, we've dragged a light in, we've dragged a box in or whatever, we've got our objects in there, so that's our data, we've assembled our data, but now we want to start putting logic into those graphs in the center. And that is going to be using the Blueprint scripting system and basically the workings of C++ or any C-like coding language. We're going to look at that in a second. But again, just going over this, it's putting the functionality in there. It is the process of designing and writing these instructions, our code, to be art when these instructions are taken out by the computer. And that just means our gizmo whirly-gigging away, But the process is breaking the task into its many, many subtasks. And we're talking to machines. They only know. You must tell them everything very precisely, and it's like talking to a little child, or it's like tedious in a lot of ways, but it's also, this is really important, it's grounding. It's kind of grounding. It's a mechanism. You can go in there with a stethoscope and a magnifying glass and see every single thing that's happening, every little thing that's ticking away, and almost 100% of the time when my code's not working, it's because I have a typo. It's because I don't have the wire going to the right place, or I didn't enter a variable where I needed to, or I have the wrong name for a parameter that I'm adjusting in a material, or whatever. It is very, very, very rare that your computer hardware will actually fail and that things aren't going right because, oh man, I hate computers. They're so dumb, they don't do, I don't want to say we're the dumb ones, but that was a funny joke to bring up. But, really, the computer does exactly what you tell it to. Every single time, pretty much without fail. And when you're not sure what you're saying, when you're not looking closely and finding your typo, it can be extremely infuriating because you haven't taken the time to dig down in there and look. And it is oftentimes, I must admit, like, I don't want to, come on, just work. I would like to just spit my code out and it works. Okay, good, move on, right? And it's almost always that I just have to slow down and go very step by step. And there's actually tools within all coding languages, and there's some really good tools within the Unreal Engine for debugging. So it's basically for tracking the flow of the functionality, and we're going to be looking at that as we go as well. But the point I'm trying to make is that it's frustrating when the computer keeps doing exactly what you tell it to, but you don't know what you're saying. But it's also the source of its reliability. Okay, the same thing that is frustrating to us when every time I hit that button, it's still coming up red, and why? When you find that mistake in your code, I like to think about the fact that means if my code is good, it's gonna run, reliably, over and over again. So the implacability of the computer is also its strength as a tool. And I mean, we run our entire world on computers, so, you know, it's kind of crazy, actually. So, you know, I would always tell people, too, with learning software, you adjust to the software. You don't adjust the software to you. You're not going to change the software, right? You have to get the perspective of what you're trying to do. And so that's why a lot of what I'm talking about here today and over this whole thing is about perspective and having the attitude that the computer is this reliable mechanism, but it's not flexible, you know? And that's its power and its frustration at times. But if you align yourself with that idea and you be the flexible one, it's badass. Yeah. Okay, so we're going to be designing algorithms to carry out these tasks that we break down into these many, many subtasks, and we look carefully at through debugging and things like that to make sure we know exactly what's going on, into larger structures called algorithms, which are chains of logic that get fired, and then we're going to combine all those algorithms into the functioning system that is your art, or your creative coding. So here they are. This is code. That's all. Everything that I do in the Dynamondala is one of these things. There may be some additional data types that I use, but there's events, there's variables, there's loops, arrays, flow controls, functions, and it all gets put together into an actor. Now remember, we're talking about the idea that an actor is made out of functionality and data. And so I've specified, as we look at these, what kind of things these are. And we will go through them in more detail as we go, but just a general running through this. Events are a form of functionality. Events are things that occur, okay? So the computer, you can start your program, and it's humming away, and you've got a world, you know, that's sitting there waiting for you to come up and engage with it, right? Even that sitting there humming away, there's some level of, we said, start the program, begin the birds singing, raise the sun, have the trees, all these other kinds of things. Those were events that were triggered usually by the first event, which is initialize program, and then it goes through some logic. And I do that a whole bunch. I have to bring my things in, I read in data tables, all this kind of stuff. I'm gonna try and, I have a demo I think that is gonna take us through these details very clearly, and I want to also throw you right into the middle of the intense parts of the places where a lot of these are being used in the Dynamondala. So I hope that we can do that. I hope it's, you know, because I think it'll be fun to see both the rudimentary and the more complex. And ideally, if I explain the rudimentary well, as we get into the complex, it won't be completely losing you, you know? So events are things that happen. Nothing happens in the game unless you tell something to happen. The computer does nothing without you. Nothing. The computer is just a stupid object until you put a script into it and ask it to begin reading. And then it can read super fast, and it can carry out your executions very exactly and really a lot of times. And that's what's bitching about computers. So events are something that happens, triggers code execution. Begin game, as I was talking about, is you know, the principal one. And then user input, as we saw, we didn't do any user input yet. Well, we did, yeah. Anyway, user input is one of the main ones, right? Hitting a button on the drum machine, turning a knob on here, touching parts of the Dynamondala. All of those are sending messages, in this case using the MIDI protocol, which stands for Musical Interface Digital Interface. It's basically a digital player piano. So if you look at a player piano, you know, the old school ones, they've got this, you know, air blasting through these little holes, and the paper drags across the surface, and the spots where the holes are open, the air makes it through, and it causes the mechanism to function, you know, and that's essentially what MIDI is. MIDI is sending different kinds of messages identified by a number for the control that it is, or for the note on the keyboard it is, and it's sending that identification and a value to go with it. And that's it. And the sending of that generates a message. If I hit a button once, that's one button, but if I turn a knob, I'm actually spamming a whole bunch of that message over and over again, right? So basically, as long as I'm turning the knob at some frequency that's designed inside of this thing, it's just hitting the message again and again. So I can basically keep turning the knob, and as long as I'm turning it in the same direction, I'm sending the same message. And essentially what my software does is based upon if this thing is sending I'm turning right or I'm turning left, I have a custom function library that I built that says I will increment the variable or I would decrement the variable. It will say if it's going to be a float variable that I'm making or an integer variable that I'm making. I can say a top and a bottom clamping so that it won't go beyond. I can say a top and a bottom clamping so that it'll wrap back around to it. I can make a button event. These are all just what's built into my library that are responses to the events generated by these machines. The events really don't change, excepting perhaps it specifies a different note or it has a different control ID, but it's really all in the way that it gets interpreted in the code once the event has started. An event starts something. In a game, an event might be that I've come within a certain distance of an object. So if I wanted to be able to open a door or flip a switch or talk to an NPC or something like that. And there's actually a whole system within Unreal called collisions, which are basically invisible volumes that surround yourself and anything in the world. And when those two volumes cross over each other, it initiates an event. And that initiation of event can say, know that I'm here, find out if I've got anything in my pockets, see if, put up the message that says push the E key to turn the light on or something like that. Okay, so that's events. And custom events, when I would make that logic and things like that, events that's obvious like that, the two collisions are touching each other or event begin play have happened, but many of what we're doing here are custom events, and I'll show you that I thought it was interesting. These are events that exist in the Dynamandala. I kind of went through and just figured out all the events that I created in various areas inside of the root. This is just the initialization cycle for everything in it, and some of these things call other things and stuff like that. And then this is some of the are in the personal just to my main root thing. This is in the Dynamandala, the palette system, and then this is inside one of the diamonds. There's all of these events really are not that, it looks like a lot, but in fact, one of these is increase the X position on the object. The other one is increase the Y position on the object. The other one is increase the Z position on the object. A lot of these are increase the amplitude of an oscillator, the frequency, or the phase offset. So these are really just like singular controls. And there's a lot of them. I just thought it was interesting to get an idea, get a grasp a bit of the volume of things that are in there. We'll look at the graphs a little bit more as we go, but custom events are really, really important for controlling where your code goes, and we'll see more as we go. So events, big deal. Variables are a data thing. Variables are the numbers and other kinds of data that we can change over time. We have data in our equations and in our algorithms, and it could be that we always need the number 4, so we have a 2 + 2 = 4, and we're never going to change that 2 and 2, right? But the whole point is that if we wanted to have an algorithm and get varying results, we could make those 2's be variable, something that we could change. So sometimes we could say it's 2 + 6 and we get 8, and sometimes it's 2 + 7, and onward. So this idea that we can build mathematical logic, and I mean really basic, like adding things together, like subtracting something, like dividing a thing by the number of layers there are and stuff like that. It's not complex math, but the fact that the digits within those equations can be changed based upon the fact that I've made a Dynamandala that's only got 3 layers, right? Or a Dynamandala that has 20 layers. I'm going to use that 3 or that 20 to control how big my arrays are that I make, how many steps I have in the palette that I generate, various other things like that. Very high level, I'm not going to, we're just getting the idea that variables there's many types of variables, and we'll look at that a little bit more. That's the principal idea of data when we think about coding a lot of times, X and Y and things like that. So loops are a special mechanism within code that allow you to look at a lot of things and check them, right? You can check them, manipulate them, whatever you want. We'll see more examples of that. One example I was thinking to show is the dynamandalas are made out of these pieces of geometry that are made in there, and if you play with one of the controllers over there, you can hit a button and have all the geometry change, right? What that's actually doing is firing an event that goes and takes a loop and goes through every register of an array, which is a list of what piece of geometry should be in each layer, and just steps it by one. That's all, right? And I can hit it again, and now it'll step it by two, and basically it just makes every mesh that's in the mandala switch to the next one in a list of available meshes that it's drawing from. Yeah?
How is that a loop then?
A loop is, it basically has a beginning and an ending value. It has a sort of a starting and an ending threshold. So if I know I want to make 20 things, I can make a loop that says make a thing, and I say do this loop 20 times. Loops are common all throughout coding. If you are doing more database kind of things and you've got a whole list of names or maybe a whole list of states, and you loop over this entire list of people and checks the names of states and say, oh, if it says California, add a check to California. If it says Oregon, add a check to Oregon, stuff like that. And you could loop over the entire list and figure out the percentage of people that are from California, the people that are from Oregon within this list that you've got, right? So that's a real dry and practical thing about it. I have an array which is just a list, a collection of multiple objects. It's a conglomerate kind of data of color values, right? I have an array of color values, and I use a loop to go through, and for row 1, grab color value 1. For row 2, grab color value 2. For row 3, grab color value 4. And I run that loop over it on a pretty relatively frequent level, so that as I change what 1 is or 2 or whatever, it gets sent to the mandala by this loop. It's going over, what's in there now? Okay, send them over. What's in there now? Okay, send them over. And that's how you get the color animating in the mandala. So, and we'll see more examples of loops. Arrays are the things we loop over a lot of times, and that's what I do most of here, but we'll also look at the most basic level of array, which is, you might say, here's 5 different responses I can give to a question, and it'll randomly pick from those 5. And all this we're going to do by hand, building, coming up. I'm just giving you the overall dump right now. Flow control is another form of functionality, and that has to do with choosing whether or not you want to do this or another thing. I use flow control to make sure that in my initialization stages I skip some of the controls so that I don't iterate something that I don't need to at the beginning, right? I use flow control to identify which control is sending a message now, and then later direct which value should be updated in the HUD and which parameter in the Dynamandala should have the data sent to. You know, so I've got one knob here that when I turn it, changes the radius of the mandala. That knob's controller number is 3. We generally are counting 0-based in the computer, so it's 0 is the first control, you know, so the 8th control is 7. It's a little weird, but it has, I'm sure there's a good reason for it. What?
I have a friend who is a programmer and disagrees, hates it.
Oh, really?
Yeah.
It's just an idiosyncrasy as it is. There's a really important part of loops, and that, see it says allows variation on there. When you do a loop, this is where you use integers a lot, is like how many loops do I want to do? There's no fractioning to that, so a decimal doesn't make any sense. Every time a loop goes, it also passes out what's called an execution index, which basically means what lap of the loop are we on now. Much of my code is built on taking the execution index, multiplying it times a smaller value, and then passing that on to the Dynamandala. So this is how I get, the radius of the first one is this, and the radius of the next one is this, and the radius of the next one is this, and I get like a cone offset from it because I have a single value, which might be 0.5 or 1, that on a 20-layer mandala will mean a 20 for the radius in the back, and a 19 and an 18 and stuff like that. And the first one will be 0. The first one won't be affected. That's why 0 is cool, because I basically can just keep it not messed with, and then the other ones are, gradually messed with. So, yeah. Okay, flow control, functionality, and then objects, as we talked about. So what's interesting is the book that I really studied a lot out of, there was a few of them, but one of the main ones, and it's in the useful links. Daniel Schiffman is an instructor. I just can't tell you enough how rad this guy is, and I owe a lot to that. He has this whole website called The Coding Train, and it's also a YouTube site. There's links for all of this in there, and he teaches processing, which we had, from the other classes. Processing is really where I learned the basics of coding, and this is essentially a chapter list of his book, up to object-oriented programming. There's more beyond this about working with other data stuff and fancy things that processing can do, but as far as what are the fundamental parts of coding, what are the pieces that we're going to use going forward, this is the summation of it.
What's the key difference between flow control and functions? They're both doing logical operations.
Flow control is specifically branching and decision-making based upon evaluations of criteria. Is this value the same as this? Is this value less as this? Is this value greater or equal to this? And that will generate a Boolean, which is a true or false result that you can then use to decide which branch of code you're going to run. Function is another way of organizing code. In the same way, and I will say, I don't use functions very well yet. My code is not optimized totally. I'm thrifty as much as I can because of my experience of trying to preserve resources when making models and stuff like that. There's more to be done with organizing and tidily tucking things away and stuff like that. A function is a way, once you have designed your algorithm and you really like it and you know it's good and you know it does what you want, you can wrap it up into a reusable block of code. So just as when we use, a lot of the nodes are functions that are provided by Epic that will do things inside the node, like get the target that you want, find out where it is in space, figure out how much it would move it by this much locally relative to its parent, and that's done. Well, I could write a whole chain of code, checking where, and all this, and have this big exposed branch, but then once I've done that and I know it works well, I'll just wrap it up in a function, and then I can use that function. And especially if I don't just make that function within the blueprint, if I make it in this other thing called a function library, it then becomes available to any blueprint that I write.
It's a library of code.
It basically is, and it's really like objects too, okay? So objects, we can make a car, and then we can instance a whole bunch of them out there and give each one a different paint job. But if we decide that we want the ability to have three-wheel cars to exist, we can go back, and maybe we're not only going to do three-wheel cars. So we go back and we change the original object to have 3 wheels, and now all of our cars work based upon 3 wheels. But I only had to change it in the object, not for each of the instances in the world. So, yes. And if all of a sudden, so I use functions when I talked about the idea that I'm going to increment a variable, I'm going to maybe wrap that variable, I'm maybe going to make it a float or an integer, I'm going to have variable amounts for how much it goes up and down and stuff like that. That is all within my function library. And if every time I hit that button and it's supposed to be incrementing by 1, it increments by 2, I can go fix it in my function library, and everything that uses that function will now work properly. So again, it's a write once, use many idea. I am not very good at employing functions as of yet, but they are a thing, and the really good programmers know all about them. Okay, so let's start looking a little bit more specifically at the subject of events. Or does anybody have any questions in there on that stuff? We're going to start looking at these individually now. Are we ready to keep going? Okay. And actually now, start your computers. Make sure your computer's on. Let's take a break while everybody gets their computers up and running, unless everybody's already good to go. I just want to make sure that we don't have any delay. Are we all good? Everybody's good? We're going to start doing some tutorial here. Okay. So events, again, like we said, are things that happen. It fires a pulse which can initiate code execution. There are these pins you'll see on them. These are called execution pins. Okay, there's data pins that have to do with the kind of information that will be passed or the information that is needed by the node. But there's execution pins that represent the sort of circuitry of your logic being pinned together. You can actually see this firing. This is part of the debugging capability that we have, and we're going to look at that here in just a second. So as we go through looking at our blueprints and trying to figure out why a message isn't going where it needs to go or something like that, there are visual representations of the energy flow through the logic that help us see what's going on, let alone the visualization that exists just simply because the wires are connecting the things together. Like I said, begin play is one of the most prominent events that you're going to encounter. That's just basically upon me starting the program, do all of this stuff. It might be put one in each corner. It might be turn them all yellow, whatever. You know, it might be go grab a reference to, as in my code, these objects. Well, I could show you these really intense initial. It's so funny. I remember when you watch TV and stuff like that, and there's techie shows, and they're all initializing, begin initializing. So I know that, trope. And I was working on my code, as it started to get more complex, I just realized that if I did that first, then this wouldn't be ready to get that. Or if that, if this tried to get it there, but it's not done yet. So the order in which you execute things based upon event begin play is your initialization cycle, or whatever the various words that we've heard. It's a real thing. I thought it was pretty cool. I was like, wow, I'm initializing. That's neat. I feel techie. And so flow control gets used a lot in that for doing it. There can be a lot of things that happen off begin play. I can show you that if we get there. So input is an obvious event. Keyboard events, gamepad events, MIDI controller, a touch event on, Unreal will support touch screens. It's just a matter of implementing those kinds of signals. This is part of the thing that's bitching about Unreal, right? It's got like a whole suite of receiving pretty much all the hardware that exists out there, or protocols such as MIDI that allow you, there's MIDI and OSC is a higher resolution MIDI, as I understand it, and then DMX is a lighting control standard that is what you go to a concert and you see somebody back there moving a board and all the lights move in this, up on the stage. That's DMX code. Unreal can run DMX code. The completeness of the game engine is a neat tool for us as artists. It's pretty neat that it'll take all those different kinds of input and I don't have to write special stuff for it and things like that. I just have to write that the event that gets triggered by that input controls something. And then, as I said, custom events. These are user-created events, and we'll see those a little bit more, but, when I turn a knob, there is a standard event that I create that is make this blueprint able to receive MIDI information. And so when a MIDI message comes through of a certain type, either a node on or what they call a continuous controller change, which is a knob turning or something like that, that is all that Unreal knows about it. It's a CC message because it's ready to receive CC messages and it gets the ID. It's number whatever, and the value is this. Through custom events, I say, Use that value to change the X position. Use that value to change the brightness of the frames. Use that value, so those are custom events that I make. I want it to be that when I hit this button, if the light's already moving, it'll stop it, or it'll start it, or it'll begin to change its color, or it'll add additional things to it, you know what I'm saying? Right, you know, and like branching could be, and conditionals. That would be an example where you say, is the animation playing? So when I push the button, don't do anything. Is the animation not playing? Okay, then when I push that button, start the animation. You know? So that has to do with, that's where conditionals and flow control really come in for allowing us to, you know, basically construct the functionality of the machine. So, and then as I talked about earlier, collision is a very common event that exists within games that has to do with just two things coming close to each other enough to say, oh, let's start interacting, which is really a core reason why objects are so performant in video games, because nothing is trying to interact with me until I get to a certain distance from it, and then we dedicate all of our horsepower to that interaction, because all the other interactions are dormant while we're not colliding close enough to wake each other up. Okay, so let's look at an example of this. Okay, this is our final object that we're going to create, okay? And we're going to do it in multiple stages. You can see that we have here a few things. We have here a color. We can change what that initial color is that we want. We can set this offset height value to what we want, and we have this Boolean called print. This is a Boolean that says print message or not. And yeah, that's funny. Okay, that's fine. So inside, oh, here we go. Inside here is code both for seeing those things in the editor as we mess around with it. The construction script is where we construct graph information that has to do with the way that we will interact with it in the world, the way that our object has user configurability as we're setting up our art and placing it in there and stuff like that. You know, this other one here is information about when I press the F key, I want you to move or not, and I'll show you more about that. So let's go to the very beginning. I'm going to close that sucker up and go to steady demonstration. There's our spheres that we had, right? And we see that they've got these shadows underneath them. If I go into kind of an empty space and I hold Control L, I get this axis that shows up in the corner, and that actually represents the position of the sun. And while I'm holding those, I can drag this around, and I'm saying where the sun is in the sky right now. And I can make it nighttime by putting it underneath my planet, as it were. Now, if we look at this a little bit more, here, where's the sun? There it is. So there's actually that sun object, right? If I, So clear and straightforward. Well, what I want to do is I just want to get back a little ways so you can see the atmosphere in action. Okay, so if now I go down and it's a little funny. There we go. See though how it turns into sunset over there, and we see the sun moving across the sky, and we get this atmospheric looking sunset or sunrise or whatever it is. You can do more with it, but this is just sort of a nifty demo thing that it's just a way. This is the directional light. A directional light represents the sun. It's all parallel lines. There's no radiating from a single source or spreading out the way a spotlight would and stuff like that. This is your generic overall lighting of the scene. And if I do this as I move around here, if I do the Control L and move it around, see how actually the shadows move over the clouds, and there's actually what's called volumetric shading going on in these clouds. And here I can get the sun to, It's a little funky control. There's other ways to do it, but there you go. So there. So this is meant to be your kind of setting environment. And as I was saying, there are these components that represent the core elements of it. The reason that this works is because we have these volumetric clouds in the sky, because we've got this directional light that's representing the sun. We've also got what's called a skylight. A skylight gives us the bounce light, what is in the shadows and stuff like that, so they're not absolutely black. These are all different things that you put in the world to give you this base level. So when you make your first level, when you say new level, and there's none of these additional levels in it. This level usage of the word, I agree, it's a little problematic, but that's why we have these, the persistent level. I'll for the sake of demonstration, I'll just do this really quick. I'll say new level, and when I say new level, this is now going to wipe out this map. This map's going away with all its levels, because just for the sake of our demonstration, and you can see that I've got basic and I've got empty. So if I do basic, create, I don't think I can don't save. Here it is. This is what we've been looking at already, right? It's got the sky and the environment and everything, and somewhere there they are. There's those basic elements that are in here. If I delete these things, the world, and I'll get rid of even these, I don't know where they are, but I'll just get rid of them. So now it's dark. So this is good to know. Under here, under window, look for the environmental light mixer. So this is a neat little tool that just lets you build this from scratch kind of environment. So I can just create a skylight, create an atmospheric light, which is the bounce light, create a sky atmosphere, which is something that's going to be able to know when the sun's low, it's going to turn orange and things like that. Create volumetric clouds, and create height fog. Now, if I want to add a new level, if I say create new and I choose basic, now I'll just go ahead and give it a name. So we'll say new layer all, just because I said, that. It's doing it, but now it's telling me, wait a minute, you've got multiple directional lights. What are you doing? You're crazy. And so what happened is that I made the same kind of level, and so now I've got a directional light here, and I've got a directional light there. Right. Okay? So I'm going to delete this new layer all. Yep. Okay, so we've got our basic level here, and then when I add a level, I say create new, but I choose blank. So when I choose blank, and we'll just say, so now I've got a level, and I can drop things in here, but see, it doesn't add all this other stuff, right? Okay, now let's go back to our original SETI. So go into the content drawer, go into the SETI class, go into the maps folder, and find that okay. I'm just closing this all together and restarting it because I went on my way somewhere. Okay, so the confusion that we all experienced as you were starting the program up in the first place and going to the third person level and not going to the SETI level, we can also fix with something. If you go under Edit and you go under Project Settings, it'll open up this window. And if you go under Maps and Modes, close this stuff if it's open. And what you want is right here. So the map you want to load, I have a different project than you, so I'm going to... my base map is called Step 2 Test Level, which if I go in here, Step 2 Test Level, I can find it, highlight it, and then go over here and click this little arrow, and it'll make it the editor startup map. So you guys can go get that SETI, what's it called? What's that base level called?
Third
third person base, and put that into this spot for the default map and the game default map here on the project settings. And this will basically just make it that your SETI level will be what you get every time you start this project up. So this is just a thing you can do so that when we open this up, you're at the right beginning place. So for the sake of our fun and experimentation today, go ahead and create a new level. Mine is called SETI Day 2. So I went up here, I said levels, create new, and I chose blank. When I chose blank, it asked me where I wanted to save it. I put it into my maps folder underneath SETI class. You can just name it whatever you want to name it. And in this case, I'll say demo level, and I say okay, and now I've got another level in here called demo level. And notice that demo level is now bolded in blue. That means it's my current level that I'm working on. So if I go up here and I say, give me a shape, a cube, or a sphere, or whatever, I'm going to want a cube actually, and I drag it into the world, that has now been added into the current level. And you can also see over here in the outliner the listing of what objects are members of what level. So everything in this world, the directional light, the exponential height fog, all that stuff, this floor object that we're looking at, those are in the persistent level, and you can see that over here, step 2 test level. It's a little confusing, it doesn't say persistent level, but that's what it is. But that new cube I just added is it's in the demo level. So this is how you know where you're putting things as you're organizing it all together. Delete that cube. Go ahead and open up SETI demonstration while we're here and look at these spheres. And remember that these on the end are ones that we have some cool variables we can mess with in. And we can also see when we look at this that these are blueprints, okay? It says edit BP UV slide. This one, demo sphere slide, is just a static mesh actor. Okay, so it's just a mesh in the world, and though it has the tile slide basic material on it, it does not have any parameters for me to manipulate variables about that material. This one is a blueprint. It is not just a sphere that I dragged into the world. It is an object in which I'm clicking edit blueprint to see it, in which I have added this thing called an instant static mesh to it, which is basically another way of putting a static mesh into my component list. Don't worry about it too much, but because I've got that instant static mesh here, I can manipulate stuff about it. Here's my functionality in my graph. Here's my data over here that says I'm going to put this sphere in the world, and I can see it if I look in the viewport. But and remember, this viewport allows us to test our blueprint as we're creating it. For the most part, it doesn't allow you to do input. Okay, so, all right. We're looking at our test level, and we realize that when we have just a mesh dragged in, even though we've got a material on it with parameters that we can talk to, we can't talk to it until we wrap it inside of a blueprint, and now I've got the ability to adjust what the panning speed is in these different directions and mess around with it all. I can choose a different texture for it. I could even choose what the material, yeah, don't mess around with that. Anyway, the point is, right, that when we wrap it into a blueprint, we get the ability to add logic to it that gives us control for it. Okay? Good about that? All right, great. Now, close that level. Let's not look at that level anymore, and let's go back to our SETI Day 2 level, which should basically be an empty level along with the persistent level, which is this other stuff in the background, and so we've got a free area to begin adding stuff. Make sure that your SETI Day 2 level is your current level. Go to Make Current. Just make sure that it's your current one. It can be easy as you're going along to not have the right one be current. So go under Content, go into the Blueprints folder, just for the sake of organization, and I'm going to right-click. I'm going to say Blueprint Class. Remember, class means the template. It's the recipe. It's the instructions. We are going to create a new set of instructions for an object that we're going to create. So I go to the empty folder in the empty space in the content browser. I right-click, and a menu comes up, and I can say, I want to create a new Blueprint class. When I do that, it's going to give me a number of selections here. This confused the hell out of me for a very long time until I really started understanding actors and classes and inheritance, like we were talking about before. Remember the idea that when I make an instance of something, I keep its structure in the new one, and I can customize stuff. So Unreal is trying to help us here. It's giving us gradually more complex base objects to start from. If you know that you're going to create a character, we looked at the third-person character the other day where you could start it and you could swing the camera around and make them walk around and stuff like that, and there was an actual visible character. That's an object. That object has the skeletal mesh of the character that runs around. It has the ability to understand input events and definition of what those input events would be, WASD and moving and stuff like that. And it has logic so that when it gets an input event W, it starts to increase the forward progression of that character. It also has a camera behind that character. That character is an object with a camera, a mesh, and some control schemes into it. If I just say actor, it's a blank blueprint. Okay, so when I look at this list, these are ones that they have pre-made for us because it's very common to make a character blueprint, right? So they just got one you can do to start with. That's all the reason that there are these different levels here. So we just want to choose actor from this list because an actor is the most agnostic object that you can have in the engine. And call it whatever you want to. I'm going to call it BP Code Essentials, because that seems like a good theme for what we're doing. And I am going to drag it into the world somewhere, put it wherever I want to. Actually, what I suggest is we put it over in front of, you should have a player start in the world like this. That's where we show up when we start the world, and I'll just put it over in front of us here. So, clicking on that label, right-click on that just top bar there, and make sure that you check level. You can have many other pieces of information. This is called the outliner, okay? So there are two different areas. There's the level browser we've been looking at, right? That's for breaking things up between the different levels. And then there's the outliner above that, which is kind of our active things we're working on sort of stuff. And one really important thing to do here, if we don't have it, is notice this is telling me that BP Essentials that I just made is in SETI Day 2. Player Start that I just moved is in Step 2 Test Level, which is the name of mine because I'm special and I have a different file from you. But you'll probably see SETI third-person base would be the name. Anyway, not having this on this level over here, if all you see is item label and type, on that type or item level, you can right-click, maybe double-click if you're on a handicapped Mac, and choose level. And then you will end up with also that category known, and it'll tell you what level it's on. You can add a whole bunch more of these, but the point is, because you may be working in different natures of what you're trying to adjust. So you want the flexibility to not have them all there because screen space is a premium. Okay? So we've got the player start in the world. We've got this blank BP in the SETI Day 2. Okay? So now double-click on that blank BP. I called mine SETI Code Essentials. You'll know that it is a blueprint because over here, instead of just saying player start or something that you can't do anything with, it's a hot link. And if I put my mouse over it, it says click to edit. So if I click on that, now it's going to open up the blueprint editor that we've been looking at all this time. It happens to be on viewport now, so all I'm seeing is what we have, which is basically the default scene route. That is just a location in space. This is how we can drag the blueprint around and see it, right? So I'm going to go back over to my event graph. There's nothing going on in here. So I'm gonna pull this off really quick and put it like that so that we can see the tabs, right? That's what I was saying earlier. You want to do those tabs so you can find things. So now we've got our player start, we've got our blueprint, and I hit play. There's nothing there.
What's interesting is when I hit play, I get all the other levels that are currently hidden.
Yes, okay, so that goes back to stop and go to those levels that are currently hidden. We were talking about this just a second ago. So like SETI demonstration, let's say. It will give you an error if it's not shown. So if you show it first, then you right click, and you'll see that it says change streaming method. And mine currently says blueprint or always loaded. Do it to blueprint so that basically it will only load when I send the load level now message. So basically just go through and clean up so that you don't have a bunch of other stuff loading. And so this would be that as you're working, you would use always loaded, even though you're maybe going to stream something eventually, you would use always loaded so that when you run, it's there and you can check it out and see how it's going. And then later you would change it back to streaming and have your code that loads it in when you want to and stuff like that. There's other things up here like snaps and stuff like that, and the moving between if I'm rotating, scaling, or just selecting. We've got the player start and a blueprint in there. Okay, hit play. Nothing there, right? So if you click on down here, I also have world settings. If you don't have world settings alongside your levels and details, it's just another window that you can find up under here and turn it on and then drag it in there as we've been doing. Something else to know about is that down here under window is the ability to load a layout, and you can load the default editor layout, and generally this is a pretty common setup that I've got going on here. So if you're ever really screwed and confused, do that. And then so instead of doing for our default pawn class BP third person, choose default pawn. And that is going to give you, and also, yeah, no, it's fine. And then when you start, you'll be looking like this. And you've got just a regular, you can look all around, and you can use the WASD keys to move. You have to be holding the left mouse down to use the WASD keys in a way that makes sense, like I'm navigating in first person. You can use the WASD without holding your mouse down, and it's a little bit more stilted. World settings, make sure game mode override is set to third person, and then change default pawn class to default pawn. If we are looking in our editor, we can see we've got this blueprint up here, and we've got our player start, but when I hit play, there's nothing there. Why? Open up Code Essentials. That's that's my blueprint. This is our beginning blueprint. The default scene route, it doesn't show up once you start playing the game, but it's there for you as you're working in the editor and changing things. So we're going to say add, click add. I personally am going to choose cube. So now, and actually this is good to do it in the viewport view, actually, so it's not abstract. Go into the viewport view. With the default scene route, click add. Choose what you like. I am going to choose a cube. You could choose a sphere. You could choose whatever you want. And there it pops up in my view. So this is code. So there's as well as initialization that we heard earlier. That made me feel like I was a professional coder because I could initialize things. There's compile, which we've all maybe heard before when people talk about code. And that's basically, before you can use the code in the world, you've got to kind of make sure that it's all straight and everything's cool. So if we just jump over here real quick and look at the world, well now, sometimes Unreal's smarter than me, and it just does things really fast. We see the cube's already showing up now in my blueprint that I just added to it. right? But I can also, if I go over here, I want to hit compile, just to make sure, and you'll see a check mark when it has been compiled, meaning the code is sound and everything's good.
And what if you get a question mark there?
That means you haven't compiled yet. It means you need to compile. So if you had something errant in there, a connection that wasn't made that needed to be, and things like that, it will also give you an error, say failure to compile, and it will give you messages. When you have more code and you're looking for it, it'll help you find problems in your code. So the reason I did that is because I just wanted to be able to see where it is, right? So now if we hit play, I see my cube. There's my blueprint, right? We're going to create an event now inside of the code. So we're going to go to the event graph. A blueprint must know that it's allowed to take input, okay? I only have one blueprint in my system enabled to take input. That's the root, because the input goes into root and then it gets spread out to which Dynamondal I want to talk to and stuff like that, okay? You don't want everything in your world to responding to your inputs, only the things that need to, okay? So you have to say to the blueprint, accept input. So to do that, we're going to go up to the event begin play, which remember is our initialization event. They give you these three events, event begin play, event actor begin overlap, and event tick, because these are very common, right? So delete these bottom two, because they're very bad. So I'm going to drag off of here and type enable input. Enable input. And so there's a lot of things that say enable, but you know, it winnows the list down for you based upon a search, but you might have to actually go and select enable input. Okay? So begin play, we're going to enable input. This blueprint will accept input, but who will it accept input from? You can say, but the easiest thing to do is go here to player controller, drag off this way from it, and now type get player controller. Player controller is 0. Okay. Player 0, if you're by yourself, you're always player 0. Okay? If you're doing co-op or something like that where multiple people can play at once, this is when this other stuff comes in. Who cares? We're not making games, we're making art. So we're going to just be player 0. And basically, remember, a controller is just a piece of the code that knows how to hear that a message is coming in, interpret that message, because you can actually code inside of the controller for the way to interpret that message, and then apply that to the subject. Okay? In this case, our subject we're going to apply it to is the self. We're going to bring that input in and use it within this thing. So this is all we need to set up that this thing is going to receive input. Okay? So that's going to receive input. What input might it receive? We're going to keep it really simple. Everybody's got it in front of them. We're going to use the keyboard. We've got a game controller right in front of us, which is the keyboard. So I'm going to right-click here, and I'm going to look for an event that is a key press. I can scroll through this list. This says context sensitive, but because I'm not dragging off of anything, this is everything. And you will find down in here keyboard events, H-I-J-K, how do we spell? But if I say I'm going to use the G key, then I will see a lot of other things that come up, but also down here under keyboard events is the G key event. Okay, I'm going to drag off of the pressed message, and I'm going to say print string, excuse me, print string. Okay, I'm just going to be a cliche, and I'm going to do what everybody does the first time, which is having hello or hello world be the message, and they've got the default entry there for what you should say as hello. Now I must compile for this code to be blessed and know that it's working. It turns into a check mark, right? Good? Yeah, you there? Now hit play. Now when we hit play, we see the cube, and you must click in the viewport for it to work. And now if I hit the G key, I see hello show up on the screen. And do you also notice, as a part of my glorious demonstration here, that I can also see event begin play fire when we started, enabling the input. And while I'm here and I hold on to this, as I hit my G key, I can see that event going from the G event to the print string node.
So I get the print string.
Right now we're building the code, and that code is present in our level in the form of, here's the blueprint, right? So I've got the object in the world, and so now, and it's easier if I do this with the code essential showing, okay, because I want to see this. I can go up here and I can hit play, and up comes my window, and we see event begin play fired there because I just started up and it enabled the thing. Did you see that happen? And now you must be clicking on the viewport. You must be in the viewport. It won't work unless you do that. And then I've hit the G key and I can see the G is, look at the screen. So we've got an event. This isn't a custom event because this is an event that they already have built for us for all the key presses so that you don't have to go around making all that, but it does this print string. So you can obviously see that you could type whatever you want to into that print string, right? But what if we then, instead on this input pin, if we right click on it and we say promote to variable. That variable's default name in my case is in string. I right clicked on the pin and I chose promote to variable. And I could have done it this way. I could have gone over here under variable and said create new and then call it, other string or whatever, and make sure that I change it to a type that is called a string. So now I could drag that variable I just created into the world. I could I'm choosing that I'm going to get what's in that thing, and I'm going to wire it into here too. Same difference basically by right-clicking on it and saying create variable. Just make sure to create the right type of variable for you, and it's very clear. Okay, so you've got your in string going in there. Now, click on that string. And look over here on the right. Does yours say, please compile the blueprint? Because we made that variable, but we have not initialized it. We haven't, if you look up here again, compile the code. So it's telling you, please compile the blueprint. So when we compile the code, it will now show us that the default value of in string is hello. That's another cool thing about Unreal is that when you do that variable by right-clicking, it'll adapt whatever value you have in there. It's a little bit of a shortcut. Okay, so now you could type whatever you want in there and then run the program, and that'll be the message.
In the print string.
In the in-string variable, right? So it can print whatever you tell it to. If you have a variable of the string type, you can change what's in there and it'll print that, right? You can vary it between different things. So obviously in here we can set it, save it, go into the world and run it, and it'll say whatever we wrote in there over and over again. But are we with me? Are everybody with me on that so far? Then now, if you look at this, over here in the details panel for it is some additional information about the variable, and one of the most important one is instance editable. You see it's unchecked right now, right? What is a check mark? True, yeah, true. It's a Boolean, I'm sorry, yeah. So the point is, remember we talked about variables, we're gonna see them in different places. A Boolean variable is a true or false switch to say if I'm gonna do something or not. Right now, it's unchecked, so this is not a user-exposed variable. So when I go look at this in the world and I've got it selected, and I'll go to my details panel too, make sure I've scrolled up, I can see its position in the world, but there's nothing else here, right? Now if I go back into Code Essentials, this is my blueprint, and I change instance editable, look over here on the lower left as well. See, this is a closed eye. If I check instance editable, that eye opens up. And I can also do it over here too, same difference. But basically that's saying this is a variable that I'm going to expose through my code for the user to change. So you might write this object yourself and then distribute it to other people to use. So you building in variables that can be edited by somebody who's using it is basically making a tool. You're also, might be making the interface that you want for your own project and the way that you want to work with it. So I've done that. I've checked instance editable. So I compile it again. And now when I go out into the world and I have it selected, I see that inString is a variable that I can choose. But dig this. If I move this guy over a little bit, and then while I'm still ready to move it, I hold down the Alt key and drag it, I make a copy. Okay, I can make a few copies if I wanted to. And this one says it should say goodbye. This one says eat burritos. And this one says sushi's better. So now, because these are objects, right? I have and each one of these is an instance of this object, these three things. So in each instance, I can edit that variable. So now if I hit play, there's still a bit more to screw things up though. Now if I hit play, here it is, and I hit I think it was G, I said G, and it just says sushi is better, sushi is better, sushi is better. What about the other ones? It's only playing one of them. Why is this? That is just an idiosyncrasy of the input value, which is it says consume input. Okay? So uncheck consume input, and it will now, if I go run the program in here and I hit the G key, I get all three of them. Well, they're over there to the side. Hold on. And so now when I click on that and I hit the G key, all three of their print messages come through. You guys with it? Basically, what we've done now is we've created an event in the form, this is our first level of functionality, which is events. Events are things that happen. One of the most basic kind of events when we're programming is user input. So what we've looked at here is creating an event in the form of user input, having the firing of that event carry out some logic, which is print a string, and we've made that string something that we can change, something that we can vary, something is changeable, it's a variable. All right, so we've started adding variables to our code. We started with our event that was the input event that caused the print string to happen. And then we've made our first variable. We made a string variable. There are a number of types of variables. There's a Boolean, which is true or false. There is an integer, which is a whole number with no decimal point. There is a float, which is a decimal number that most often gets used for positioning and things like that. We've seen that there's a string, right, that can be any text you want it to be, any name you select off a list, whatever. And there's also a reference is an important variable to understand in that the reference is what am I talking to, right? So if I look at what we're doing here, we go back to this. We are going, in this case, to talk to ourselves. See, the target for the input is going to be self. References become more important when I am trying to have control of this, go through a central organizing blueprint, and then have it say that Dynamondala over there adjusts things up versus that one over there. So I actually have a reference in the code that will default to pointing to the first one, but if there's many of them in the scene, I can change that reference to don't refer to this one, refer to that one, refer to this one. So, and then whatever I do control-wise will flow to the reference. The many that I have are all instances of the same object. So therefore, they're all going to receive the MIDI data and know how to deal with it. It's just which one of them am I currently adjusting, right? So if you'll look when we run the Dynamo, and we can get into this a little bit more later, if we want to, I can tweak radius and elements of all kinds of elements of one of them while the other one doesn't respond, or I can tweak them all at once, and there's just different ways that I do that. As a matter of fact, when I tweak them all at once, that's when I use a loop so that it goes to every single one in the scene, right? So I'll send a variable and it'll loop through an array of all the dynamondalas that are in the world and do the same thing for each one. Or I can talk to one at a time. But that has to do with what the nature of my reference is. Okay, so initialization and type in variables. When we're talking about processing, when we're talking about other text-based coding that we might be familiar with, there's a more formal process of declaring the variables and initializing them. Basically saying, I'm going to need a float, and I'm going to call it, decimal. And I need an integer, I'm going to call it counter, etc., right? So if you're coming from the world of doing text coding, of doing processing or something else, and you know about this idea of declaring a variable and then initializing it, it's an important step, and it's really important to be comfortable with and do right, and many times your code will be not working, and one of the typos you will find is that you have declared it incorrectly or not specified the type properly or not initialized it. Well, with Unreal, that is all still happening. This is code. This is not training wheels. This is absolutely full-fledged code. And they're over here, and when I say this is a string, that's me typing it. That's me specifying the type that it is. And when I make a new variable, and I'll say I make a new variable, my new variable is a float. So it is a decimal variable, and I'm going to call it z offset. And so it's worth nothing because look, it says please compile the blueprint. Okay? That's because I have not compiled it yet. That's why I see a question mark here. So the variable hasn't been initialized as of yet. It's not a complete and formally proper variable. All the things that you would normally do in text in a coding language we're accomplishing here. So I just want to make sure that that was very clear. So when I hit compile, you'll notice that now this variable does have a value, which is 0. Any number generally, defaults to 0. And so basically, now I don't need to worry about declaring and typing this again. I can use it going forward, but that's part of what compile is about. And for people that are familiar with variables and coding, I just wanted to make sure that I brought up that subject because it's part and parcel of normal coding. So you wouldn't trust a language that didn't involve initializing your variables, basically. So who varies the variables? Well, it depends. Your user can vary the variables. When somebody stands in front of the Dynamo controller and touches the controls and stuff like that, they are varying the variables within my structure. There's two kinds of variables we've been seeing right now, the ability to type in what it's going to be, the text is going to be. We saw yesterday the ability to set a slider that would control the scrolling speed of the texture. These are generally user exposed and instance editable. Well, a variable must be instance editable for you to do anything with it. You just have to declare that's true. But user exposed generally means, user exposed also means that it can be changed. Those terms, though, are most applicable when you talk about the fact that I can take this world that we've got and have 3 instances of the same blueprint, but have a different message in the print specification for each one. Although I don't have a different message. Maybe I do. I have one that's different and the others are the same. This string is a user-exposed instance editable variable. Instance editable variable. For every instance that I put into the world, I can change this variable because I've declared it to be thus in that control. That's when we open up the little I thing, right? So who varies the variables? One is that you have them like this, where they're part of your interface for putting your things in the world and setting them up the way that you want them to be. And yeah, it's generally for setting up gameplay mechanics by designers, but then also changing the variables as your code runs. There's two major things that we would do with variables: getting and setting. So getting just means going and recalling from your structure what the current value of that variable is. So when we enter our own message in the print string variable and our logic calls print string and it sees that it's got this variable on there, it's going to get what that value is and use it as a part of its logic. When we set a variable, it means that we're going to change what that variable is. So all of the Dynamondala controls have a base setting. It might be the radius, how many layers there are in it, the color, the size of the objects in it, and everything like that, right? And that's your like initialized value. And when I turn a knob that's on the size, let's say, and I'm using an incrementing value of 0.1, if the thing is 1, then if I turn it left, the first event will take it down to 0.9, the second will take it down to 0.8, okay? So I am getting that value so that I know what it is, and it's in my interface to start with. I am manipulating that value by turning the dial, which generates an event and causes a string of logic to fire. That logic literally gets the value and then runs it through a function. And the function that it runs it through will alter the value via algorithm or the logic of your code. And I have set up a way of knowing what kind of variable it's going to be and being able to increment that variable upwards or decrement that variable downwards based upon the programming I've put in there for if it's going to be by a factor of 0.1 or whatever. When I've completed the manipulation of that variable, I must set that variable. Just because I've grabbed the value and run the logic and now the number is not the same that I end up with as my answer from the logic chain, I have to take it from that logic chain and say, and now set that variable. Write it back into, so that the next time I come back to that one, I will start from where I left off. Getting and setting. As I understand it, I don't know a lot about, about professional code, but people write getters and setters as individual objects or something like that. So anyway, getting and setting is something you'll hear about all the time. When you're working in the editor, and we're looking, say, at our, this is it. So I've got this variable here, z offset, that we just made. And that variable by default is 0. If I drag that variable into the world because I'm going to use it, I'm just left-clicking and dragging, it actually asks me, do I want to get it or do I want to set it? So if I say get, it's just going to be this node that represents that variable. It's got the name on it. And if I drag it in and I say set, it's going to now change that variable, and it has a pin inwards for us to make that happen. So we could have logic here that says we drag out of that variable and I type a plus sign, so I get, that's an equal sign, sorry, my plus sign, and I get add as the operator that I can use. So now I've got an add node, which I can put something in here, right? So I could put a 1. Now the offset's going to come in, it's going to add 1, and then we're going to set that value. I'm going to go ahead and drag off here one more time and type print string. I'm going to maybe spell right. We'll see. Print string. And I'm going to put, well, I would put this z offset value, but if I do that, then I'm just going to get a number there each time. And also you'll notice that it's changing this number from a float into a string. That's just a conversion of the data so that this thing will understand what's coming in there. But now there's nothing else in here, so I'm just going to get a number every time, right? And that's fine, but we can be a little fancier than that. So I'm going to delete this and pull it out a little farther. I'm going to drag off here and type append. One of the most useful nodes in the entire thing is this print string and this append node, because we can do with this is we can use it to follow what's going on with our code. We can put print strings at different places in our code, and we'll find out if anything's if we're getting there, basically. It can be the beginning of figuring out what's going on. But so I notice I put append on here, and it's got a wire going out the back, and this just allows me to build a more complex messaging tree. So let's say, if I just in the first one, I'm going to say z offset equals, and then I'll do a space afterwards, just because this way the next entry will be a little bit away from that equal sign and I'll see it. And so then I'll take this z offset, after I've set it, then out the other side will come the result of what I did, or I can do this way. I can drag it this way and put it in there. And that's just a conversion again. Or I could also just go over here and get z offset. And when I get z offset now, it is going to happen after set has occurred. So z offset was 0. This added 1, and then it was set. We don't have a logic, but I will. And then I got z offset again. But I got z offset after it had had 1 added to it, so the value of z offset will be 1 in this case, not 0, which is what it would have been had I gotten it here before the logic occurred. So let's just go ahead and make another event, and we'll just pick another key. I'm just going to say, I'm going to use the J key now. And there's J. And so now if I press J on there, it is going to get z offset, add something to it, set it, and then tell us in the print string what happened. So I say compile, and I save, and I play, and now I've got these guys. I can still hit the G key that I had before and get their print strings coming out. But if I hit, or did I say J or G? J, thank you. But if I hit J, now we see z offset is 1. Now z offset is 2. Now z offset is 3, 4, 5. See what I'm doing? Every time that I hit this button, it takes whatever z offset is and adds 1 to it, and then it sets it. That is an event, driving logic, working with variables. We are varying the value of z offset by getting it, altering the code, and then setting it. Cool? All right. I'll leave that there for now, but I'll move it out of the way. So I'm going to grab all of these together like that. I'm going to hit C on my computer, and that puts this frame around it. And what that says in it is comment. So this is a way for you to document your code as you go. Commenting, you may have heard about comment out code and stuff like that. Commenting is a way to put notes into your code so you remember what the hell you designed. I will tell you that I spend many times reacquainting myself with code, well, you just forget, and you're getting into these complex and deep operations, and you kind of have to spend a day being focused around this one task you're trying to do to be able to re-understand all the code and then figure out what you want to do with it differently. So it is very, very good practice to comment your code like crazy. Right now it just says comment, but that means because it's just blank, and I can start it here and I can say simple set, alter, get example. Now I know that that's that simple set, alter, get example that we did. Now notice I can move it around a little bit to make it encompass my nodes. And now I can easily grab this one and just move it around and take the whole thing with me. I can also go up here and say show bubble when zoomed over here in the details panel, and that'll then tell me what that comment is. And so that's really good if you look at, say here, BP root seeds, I've got comments all over the place just so I know what's going on where in this stuff. And I also have comments like this. Edit current diamond CC based on table of stored data read into struct that has a layer actor holds. We'll need other input for note on message? Huh. But if that's true, I need to merge the functions and let it change my variable. So the point is, if you are going to distribute this code to other people, comments are a way in which you can make your code comprehensible to those who will get it from you. When you are a new programmer, like we all are, I use the comments just to explain myself to myself. So there's no limit to what you can write in your comments. I have cursed myself endlessly in comments. I have, anyway, the point is, take the time and comment profusely as you go just to keep your head wrapped around what you're doing. It's a really, really important, powerful part of doing good work. So now I've got this simple set, get, alter example. I'll leave it up here. I could even put in at the end here, based on, quote, J, meaning that it's the J key that is my input there. There's no formal right or wrong about what's in your comments. It's whatever makes sense to you. You are maybe going to work with other people and have them use your code, so you don't want all the F words in your comments to be there necessarily, unless there's somebody you know well. You know what I mean? But I mean, basically, use the comments to keep yourself clear on what you're doing, and especially early on, when you're going and you're trying to do that breaking down of everything into little tasks and stuff like that, I have many times sat down and just verbally typed out what I expect the logic to be doing here so that I could figure out the part that I haven't honed in on yet, the detail and the step that I haven't realized, oh, there's actually 2 steps here. And so that can be a way to help do that breaking down of the task into into all the individual steps. Right? Okay? Good? Yes? Okay, so let's continue on with cool stuff. I don't like this message anymore. I need this message sometimes, but I don't want it all the time. So how would I decide if I do or I don't want to have this print happen? I would go ahead and right-click and type branch. Branch is a node that is one of them, that's the basic level of conditionals, in that it has a true or false condition. It's default to true. I could check it or uncheck it to true, but let's make it a variable instead. So I'm going to right-click on the pin over here, and I'm going to say promote to variable. It will automatically create a Boolean type because that's the only kind of type that goes into that slot. So that's taking advantage of the way the engine works. And then we'll give it a name, and I'll say print message with a question mark. Actually, I would say print message, and I just said print. So this is just a name I'm using so that I know what this variable is for. What we want is we want to have the ability to say whether or not this is going to print. So first of all, we need to make sure that this variable is something that will show up in our user interface. Right now, it is not user exposed. The I is closed. If I click this, now it's open. This means I can set the status of this variable. I'll hit compile so I can see this. And I go into the level, and now we see that I have the print message variable, the Boolean variable, as an option that I can check or uncheck. So now we got to make it be the thing. So I'm going to go into here because the G event is going to fire, and then a condition is going to be evaluated, and the code will either true, print the string, or false, do nothing. So now if I say compile, and I go over here into test level 2, this one here on the end says sushi is better. I'm going to not print that message. I unchecked print, so it's now false, and I hit play. And when I hit the messages, I see just goodbye and eat burritos. because the last one, its Boolean value was set to false to turn it off. So if I go back here and I say true and hit play, then now all three of the messages are coming through. Also, because these are all the same object, that means these other ones also have the check mark. These axes that show up on the objects, that's not for the cube actually. I can do a little trick here. If I go to the cube and I say I'm going to move it up in the air, so I move the cube up in the air. When I select here, Code Essential, see it's actually the root is of this blueprint. This icon is the blueprint root. This is a child of that blueprint. So we can have a position different from this, right? I can move this thing around in the world and it'll come with it because it's inheriting its position from the parent, and then it has its own position on top of that available. And notice, not everyone changed when I changed this because this is an instance, a unique instance with the ability to set these values. Now, forget about that for a second. Okay, so we're going to add a local offset to the cube. We have a new event. It's called cube jump, and we are going to add a local offset to the cube. Right now that local offset is 0, 0, 0. So I'm going to go down here in Z. I'm going to type 100. And now I'm going to go up here. We are not, I'm not going to use cube jump here. Delete that. Pardon me. This has to do with the way I want to do my demo. I'm going to change it to, I'm just going to do another key. I'll do the V key. Z key. There we go. Z keyboard. So Z is going to be my cube jump. There we go. So it's moving up 100. It's adding a local offset. Compile. Save. That's just become compile, save. Just becomes a form of habit of how you keep going, right? So I've just got a keyboard event that's going to add a local offset to our cube. So here we are, and I hit Z, and and there it goes. Now notice only the last one is working because we have the consume input on still. So I'm going to go over here under the Z key and turn consume input off. Compile and play it again, and now every time I hit a Z it adds 100 to it. Now dig this. Take those right there, copy and paste them down, and just put them right there. But change 100 to negative 100 and drag this local offset's execute pin to the released button for the event. So now when the Z is pressed, it will add 100. When the Z is released, it will add negative 100. Compile and run, and we get all right, now let's get a little bit more clever. Go back in here, and I'm going to right-click on this right here, and I'm going to say split struct pin. When it is like this, when it's 3 horizontal, it wants me to send it a vector. A vector is 1, 2, 3 floats grouped together into a single unit like we were talking about before. So I only want to make it jump on Z. I don't care about X and Y. It's going to stay as it is. So I want to, instead of trying to put a vector in here and leave it in 0, 0 and X and Y and then just change the value in Z, I can go ahead and say split these struct pins. This will still work as it is because we've entered 100 in right here and a negative 100 right there, right? But if I go to delta location and I right click on it on the first one, and I say promote to variable, it's going to automatically make me something called delta Z. And if I say compile so that everything's good, we'll see that delta Z is automatically 100, which is that value that we had before, right? When we were entering it by hand. I'm also going to make this value be instance editable, which means that now if I say compile and I go in here, I've got these guys selected. I'm in my details panel and I've got delta Z location and I can change what that is. So I'll make it 150 now. And I'll save just because I have good habits. And I'll say yes, play, and now if I hit it, Z, it goes up. Now that one went up 150 because I had it uniquely different. And then if I let it go, it comes down. If I do it again and I keep doing it, it keeps going like that. But notice how that one on the left is creeping up. Why does it keep creeping up? So basically it's 50 higher than where it started. And so it will just continue to kind of escalate as we go. So if I was to take this though and drag it in here and do it, compile, go back in here, it's set to 150, and I hit play, Z, or well, click in the view, Z, it goes up, and when I reduce, it goes back up. Wait, it's just going up. Okay, why is that happening? Why is that happening? What's going into, look at the code, and what's going into Z? It's adding 100, and then when I release, it's adding 100. And when I touch it again, it's adding 100. So it's basically always doing 100. So what we can do is we can take this delta Z, and in this case, going into here, we can drag off, and we can hit the asterisk, which means multiply most often in code. So it'll give us a multiply operator. And in this multiply operator, we can make it be times -1. So now that is going to negate that value. 100 times -1 is -100. So now, when I put that in here, this value, whatever it is, will be positive here, but negative here. And so that means I can set one value, I can select this one value of 150, and now when I hit play, and I hit Z, I gotta click in, I hit Z, it's gonna go up, and when I let go, it's gonna give it negative. And so now it just goes up and comes back down, but I still only have one variable. That is, huh? Well, it's only one variable. It's variable because I can go in my interface here and change it to, 500. Only changed a variable in one place. I didn't have to go change and add a commensurate come down variable of -500 because this one variable gets used in its positive form in the first one and gets negated before it gets used in the second one. And that way I end up with something that will go up and then come back down where I want.
Can you just go through that?
Yes, I can, absolutely, absolutely. No, absolutely, absolutely. So here is the event, Z.
Yes.
Event happens when it's pressed, you get an event. When it's released, you get an event. The pressed one goes into add local offset to the cube. It adds a local offset of x0, of y0, and of z delta location z. So whatever it is in there. So when this one gets fired, it just takes whatever's in this value and uses it. When this one gets fired, when this one gets fired, it uses this value in its z offset. When this one gets fired, it uses that value too, but it multiplies it by -1 first so that it becomes a negative value. So now I can set this value to whatever I want. 2,000, 100, 3, whatever, and it's always going to jump up and then come back down. Jump up and come back down. Got it? So this is 1, what is a float variable? We're seeing that. 2, a little bit of logic showing how you can use one variable when you really need two different values. You know, you need a positive value and a negative value version of it, and this is a way that shows to build an algorithm that will do each step that it takes to achieve what we want, which is for the thing to go up and then come back down. See, when you see it happening like that, like just hearing me talk about it, yeah, maybe you know what I mean. I don't know if I know what I mean. But when you have this direct visual feedback like that, you know, you could now, once you kind of get this going, you could go, and also let's do this really quick. Let me say, from this view, I'm going to say play, and I'm going to make this window smaller, right? So we're playing it in this separate window, and if I click on there and now I hit Z, I can see the logic firing in my code. So when I press, this one fires. When I let go, that one fires. So, you know, it's confusing unless you have a way to watch each individual component happening. And so this is, not component, each individual step happening. And so this is another example of the ways that you can see what's going on, where it can really become a tangible physical thing, not just abstract. So the code firing is like that. Okay, we're about to take a break, but I'm going to add one more thing in here. Okay, so we have been working so far in the event graph. The event graph is the code that runs when your project is happening. That's when the code is running. Now, there's another graph here right next to it called the construction graph. The construction graph is, instead of having events where you push a button or create, you know, some kind of event that's going to get fired, there's this thing called construction script right here. And this is a graph specifically for doing preparatory work to your blueprint, to getting things set up. And as I understand it, what I'm going to show you is cool, but the construction script can be problematic in some other ways, so just know that. If you try to do too much in the construction script, it can cause issues. But if you're setting up basic configurability within the engine and the user ability to, you know, drag around and change stuff and things like that, we couldn't put what we just did into the construction script because the event graph only fires is the only one that fires while the game is working. So inputs like button pushes and things like that have to be in the event graph. What I want to do now is I want to make the color of the box change with every time that I push the button. But it's not going to be based upon the button push. It's going to happen every time it comes down. It's going to change its color, okay? So to do that, first of all, we have to make the material of the cube be a dynamic material instance, right? Be something that we can change. It just so happens this cube is a default object in the Unreal system. So if I click on it and I say browse to asset, no, actually I click here and I say cube. Here we go. In my blueprint, I can list where these things come. If I go to cube and I see its cube right here, I can also see that its material is basic shape material. Okay, this is the standard cube. This is something about Unreal to know. This little icon means find where this thing is stored in your resources. So basic shape material, if I click on that, it takes me to the content browser and there's the basic shape material. This is the material that's on all the basic shapes we put in there. I'm going to double click and open up that material, and it's got two things. It's got a roughness value and it's got a color. And this color is a param. It's a parameter, meaning that if I make an instance of this material, then I will be able to adjust the color in real time, right? Because it's a parameter. It's a specially declared type of value that upon the instancing of this, that becomes a parameter that I can mess with. Let's go back here and look at, in this folder again, there's this basic material shape, and if I right-click on it and I say create material instance, here it is. And now when I double-click on it, so instead of seeing the graph and the preview and all that stuff like I'm going to build it, this is my instance of the material, but I do have the roughness and the color that I can adjust because these are parameters in the material, right? Meaning the color is a parameter I can manipulate. See? Got it? These are addressable things. So that is just for the sake of demonstration. I'm going to go back over here in the code essentials. The cube that I'm using in the world has that basic shape material on it. How you guys doing over there? Ready? In the construction script, I'm going to grab a reference to the cube and pull it over here. And there's a really cool node. If I drag off of this and I go create dynamic material instance. So what we've seen so far is in the content browser, I can create an instance of that material. Now I've got a material that has the structure of my original, but I can adjust details of it. And then I can assign that material stuff, right? If I was going to have 70 or 80 of these cubes, if I was to go by hand make an instance of that material that I would set the color in each individual one, I'd end up having a folder full of these material instance assets, which is, you know, messy and sloppy and things like that. By using what I'm doing here in the construction script, I can say we're going to make a dynamic material instance of the material that's on this object. And it's doing it all at once. It's saying, grab the material that is on this object, make it into a dynamic material instance, assign it back to the object. Now this object, and that's via the blueprint, right? Now this object, when in the world, has a dynamic material instance on it, and therefore we can change its color with code. Unless it's a dynamic, meaning changeable, then we can't change anything about it. It's just because it's just gonna, you're not telling it it's gonna change, and so it's gonna always use just exactly what it is. So this, and I need to take this construction script node and put it into there, okay? So that, the event here is a special type of event that's for the construction script. It's an event nonetheless, but it's just basically fired every time you change anything about the object when you're in the world. So like if you drag it around and move it to a new position, if you move it up in the air, if you rotate it, if, you know, anything you do, and what that does is it's basically saying run all the basic setup code every time you make a change, okay? Right now we're doing one very simple thing, which is making the material that's on it into a dynamic material instance so that we can manipulate it later. Now, I'm going to change the color while the program is running, okay? And so this construction script only happens while I'm moving things around in the space, okay? So I want to be able to address the data in this dynamic material instance that was created on the object. So an easy way to do that is we're going to use the kind of variable I talked about before called a reference variable, which just basically means right at this moment, what it's saying here, see how it says on here, it says return value, right? So this node, as I said, goes to the mesh, finds what its material is, makes a dynamic instance of it, and then assigns it back to the mesh. And it says, here's the material I made, just so you know about it. So what we can do is we can right-click here and say promote to variable, just as we've done before. But you see, it becomes a set variable rather than a get variable. Because what we're doing, and I'll type the name in here, I'll call it mesh color. So what this is doing is this is storing a reference to this dynamic material instance that was just created in the construction script. And that reference is a variable that's right down here now. And so if we go back over to the event graph, that reference is right here. We have that now to be able to manipulate. So now I'm going to grab that mesh color reference, the material reference, I'm going to get it. So now I've got access to it because, by virtue of the fact that I have a reference. A reference is just an address. Somewhere in the RAM on this computer, the code has gone and stamped out a little space and called it code essentials. And inside it, it's put the data for this cube, and it's put that there's an event for pushing some buttons, and now it's just put in a dynamic material instance that we can use, that it is, getting its data from in real time. So with this dynamic material instance, this is just a single little node. I understand it doesn't look like what we've seen when we're doing color pickers and things like that, but it is a whole material. I can drag off, well actually, excuse me, I'll do the compile so we can see that now. Then down here, it looks like I could add a material in here. It looks more like a material slot. But what I'm going to do is I'm going to drag off of this. I'm going to say set vector parameter value. And that's just looking for the thing I want. And I click on it, and there we go. So now I can set a vector parameter value in this dynamic material that we got. If we go back and look at this material, we can see that the color of it is called color. That is the name of the parameter in this material. So I'm going to just copy that text. I'm going to go back here into Code Essentials, and we're going to set a vector parameter value on mesh color, and we know that there's a parameter value in there called color. So now we're getting access to that material and to the parameter called color. I'm going to add a custom event here to my graph. Just add a custom event. I'm going to call that custom random color. Or I'm going to call it randomize color. The names of variables is an ongoing discussion in all cases, and I've been counseled many times to not use abbreviations. Basically, you want to save space and you want to be efficient, but if all of a sudden you've got variables named Z and 9 and 13 and stuff like that, you're going to get insane really quick. Okay, so now we've got randomized color, which is going to call the set vector parameter value. But right now, the value it's going to use is just pure black, right? So we're going to make that something that we can set. We're going to do that by dragging off of here. And instead of saying turning into a variable, we're going to just let go and see what's available to us. And down at the bottom is make linear color. So a linear color is a kind of vector. It is an assemblage of 4 rudimentary values, rudimentary variable types, which are floats. There are 4 floats in here. 1 for the red channel, 1 for the green channel, 1 for the blue channel, and 1 for the alpha channel, which a lot of times is opacity, but in this case, it doesn't matter so much. So we know that this is a linear color structure. We can see that. A structure is this putting together of variables into a greater variable. And this one is of color. So we've got RGB in here, and right now those values are 0, 0, 0. So black is completely appropriate. That's what it should be, But what we can do is we can drag off of here, and we can choose we want a random float. A random float, and if I go down a little bit here, random float in range. So if I do random float in range, and I have my minimum of 0 and my maximum of 1, which we know that the color goes from 0 to 1, because it's a what? Normalized, that's right, normalized. Normalized, from 0 to 1. It's a normalized value, meaning from 0 to 1 is from nothing to complete. So I'm using a random float in range for the red channel, but green and blue are still 0. So we could do this, but if we did this, then we're going to get the same random value for each one, and so we're really going to get just random levels of gray. So what I'm going to do is I'm going to copy this and paste it, and so each one of these is going to come up with their own random number. So I go G and B, and so now every time randomized color event happens, it is going to make a random value for each R, G, and B, use that to make a color, and then set the vector parameter in the mesh color material. Make sense?
Does that actually work?
Well, not yet.
No, because we're not on the blueprint right now, right?
Well, we're in the blueprint. No, you're not in the construction graph. This needs to be in the event graph.
Yeah, I know.
Okay. So we've got a custom event here, but we need something to call that event.
Oh, we need to connect.
This is just we need to connect it to an input of some kind.
Right, the one that we already have made, right?
Well, we could. How would we do that?
Take it up to the Z key.
Well, okay, I'll type. So here's the thing. Now I've made this custom one down here, right? So now if I go and I type random eyes color, then I do see that there's something there. And what that is that basically as I add custom events, they become available for me to call. And now, see, there's no input pin on this custom event. But a custom event is by nature something that you can call from within your code by creating one of these. I've made this node that is about calling the custom event because I've created the custom event. And so what I'm going to do is I'm going to go take this randomized color and move it over here behind the drop down local offset, right? We have the positive that puts it up, and then we have the negative that drops it down.
And that's when you want
And then after it's dropped down, I'm going to randomize the color
you put it underneath it.
after it. So it's a chain. I can keep chaining and chaining and chaining logic together. So the point about this is putting them in the order that you want, right? So what's going to happen is Z is still the input that we're going to use. Z is still going to add a local offset up, and when I let it go, it's going to add a local offset down, but then it's going to also fire the randomized color value. So if I say compile, and I go ahead and play, this should work, and we'll see. Maybe I'm wrong. But let's watch the graph too, that's good. I click in there and I hit Z and they go up, and then I let go and they all turn different colors.
That's rad.
Isn't that rad? Creative coding. Let's go back to our original first print ever where it says we've got print message and we've been turning it off and we're not printing anything, right? Okay. So we've been talking about the core elements of programming, of which there are events and variables. I actually have these in the wrong order. I wish that I had arrays first, because that's what we're going to do next. So I'll change that. But anyway, we have events that are things that happen and cause things to go on. Input is one of the most common events, but we also have custom events like we just saw when we created the randomized color that gets called by our code at a time that's clever and we like. We could have called randomized color after the first one, right? So if we were looking at this code here again, and we have randomized color after it drops down, we could undo this and go up here and then put randomized color when we raise up. So now what's going to, oh, and it didn't compile. I think it compiles automatically. So now if we do that, now it's going to change color when it goes up. See? So it's just a different behavior. And it's up to us to choose what we want to. But the point is that it's, instead of having change color, this is just the randomized color event. So I'm going to put it down here and I'll put a comment on it and I'll say randomize color. So now I've got the functionality to randomize colors, but I've got the freedom to put it when the thing rises up or when the thing drops down, or I could make it when I push a different button instead of having it chained onto this other logic. But because it's a custom event, it gives me the freedom to call it when I want to and to really control the sequence of when things happen. So we talked about data variables. We've seen that a Boolean is a true, false, and we use that with a branch to decide whether or not to print. We haven't seen integers yet, but we will. Floats we've seen mostly that are for how high we went and stuff like that, but also it's floats that are going into the RGB values, right? No difference in the nature of those numbers, it's just the way in which it is being employed. A string we've seen as a variable in the form of what gets printed by our print strings. And then a reference here is a variable that is, it's a reference. It is a knowledge of the location of something in our code that we want to manipulate. In this case, it is the dynamic material instance that we created in the construction script and stored as a reference called mesh color, so that then when the program does run, so that's what's happening really in the construction script in the editor, it's making a dynamic material instance and it's storing a reference to that. So that when we run the code, the object will already have a dynamic material instance that we can change the values on, and we know how to get to that thing so that we can do stuff with it. Okay, so we're now going to get to the next parts, arrays and loops. The Dynamondala is largely arrays being manipulated. Arrays are groups of values that are stored together as a list that is itemized by an index value. A list of things labeled with indexes 0, 1, 2, 3, etc., for however long it is. Anytime an array requires multiple instances of similar data, it might be a good time to use an array. It's dealing with many things in one place. We loop over arrays. Okay, this is more than you need to hear right now. So let's go back here into our event graph, into our print message. So right now we've got inString as a user-definable variable we can say in there. I'm going to change that. I'm going to go here, I'm going to say variable, I'm going to say new variable, and we're going to call this string array. Okay, so I just made a new variable, I called it string array, it automatically got created as a Boolean, so I need to change it into a string, because this is what I want as a string, and right now, these are identical variables, okay? But I'm going to go over here to where it says string, and next to it on this drop down, I'm going to click the button, and I see it's single set or map, or single array set or map. I don't know what sets and maps are. There's some kind of other form of array that you use in a different way. I don't care. I don't need them. So an array is a list of things, and so an array in this case is going to be an array of strings. So what that means is that it is a string variable in the first place, but if I want a number of strings in one variable, I can create an array. And I can access this number of strings in this grouping using indexes into them because each letter, each one in the list is an index. So I've changed that stuff, but I still haven't compiled, so it doesn't look like anything down here. So if I hit compile, now I've got a string array, but there's 0 elements in it. So it is ready to receive stuff, but we haven't put anything in it yet. So I'm going to click on this little plus sign here, and I'll just click 4 times. So now I have 4 string variables in one array. If I go over here and I drag this string out here, and I say get string, we can see that this has a dot and this has this little box thing, right? So that's a little visual cue that this is a string, but it's an array, and the other one's a string, but it's just a single thing. So now if I look at this string array, don't know why that closed, but here it is. I open it up. I've got 4 entries into it. I can just add 4 words into it. Okay, so now I have 4 different strings in this list. You could keep adding more if you wanted to. Arrays are flexible in their size. You just kind of define them. So now I've got these 4 strings. So I'm going to put that into my string. But it doesn't work. Why wouldn't that work? Basically, it's because I don't know which one of these I am going to use. Right? It's a list of 4, but just dragging that in is going to print all 4? I mean, that wouldn't really be right. That would be like an append node, right? So with arrays, you have these indexes, index 0, 1, 2, 3, and you use those to identify which one you're going to pick. So if I drag off of here and I say I want to get, G-E-T, I'll use copy in this case. Get a copy. So now, this is going to go and get one of the strings out of our string array. And then, if I take the output of that and plug it in, it works.
Randomized by default?
It is not randomized at all. So what, no?
Access the first one?
It's going to, right now, it's just going to give us 0 every time. Position 0. So it's going to, so if we look at what our array is, it's just going to tell us goob over and over again, right? Good observation. So we could do 2 things. We could pull this off. We could say promote to variable. We could say string choice. And we could set that to instance editable. So now if we compile and we go into the world, we're going to have the option to say string choice. This says 0 right here. And so I could be 0, 1, 2, or 3, and it'll print that string. So I'll make it, 2. And so now when I say that and Z, but the problem is I don't have my print string checked. There we go. So now if I go in here and I hit the G key, I see vapid, right? That's because in my code, I have my instance editable string choice variable at 2. And when I look at my thing, I see that entry number 2 is vapid, okay? So I could change this. Instead of having a specific variable plugged into this, we could do what we just did before, which is to say random integer in range. And I know that I have 4 things in my list, so I'm going to set my minimum to 0 and my max to 3, because it's 0-based counting, right? So now it's going to randomly choose which string it takes out of the array. And so now, as I print bats, pendulum, you see it's just randomly choosing every time. It's randomly generating that integer value, and that integer is what's the key to go and retrieve a string from the array. So we have now hit a point where useful examples of arrays are harder and more complex to demonstrate than I might show you by just looking at my code from the Dynamandala. So give me just a second while I show you this, okay? So this is going to be more of a watch what I do than a follow along kind of thing. What we haven't looked at yet is loops, right? So we've talked about arrays, but we haven't really looked at loops yet. And I have a way of showing you loops with what we've done so far, but I want to just take a sidetrack really quick and look a little bit more at arrays because it will bring loops in. Loops and arrays very often go together because an array could be a list of team member, the practical applications are arrays will be a list of people that are there, or we talked about the idea of, lists of what state people are from, and I might loop over that whole list and categorize who's from California, who's from Oregon, and stuff like that. This is, one of these objects, the Dynamandala, and basically there's a certain number of objects around. Actually, if we go back over here and look at it, this is the primary end of the Dynamandala. This is the initial thing that gets created. But there's 8 pieces going around here. It's got a certain basic radius and stuff like that. But then you can see as we go, we've got these rows, and with each row, things are changing as we go out, okay? Every row in this, actually and we can see this a lot by looking at interior structure of the Dynamandalas. So as I said before, the Dynamandalas are objects, just like we've been doing. So if I open this up here, actually, well, never mind, I'll explain that. I'll just go here. This is the code for the Dynamandala. Here's that crazy initialization that I was talking about. You can see there's a whole lot of stuff in here, custom events. These are singular custom events like we've seen, like mesh size oscillator layer phase. That's one event that ends up getting called ultimately by a knob that I'm turning here and things like that. The blueprint that we're looking at here is like we've been dealing with all along. It's there's our event graph going on in here. There really is nothing going on in the construction script here. If I go in the viewport, we can see this, but see, that looks different than what we're seeing in the world, and that's because things have been changed on the instance of it in the world. So, we've been dragging things into this world and making stuff. This, just to have you all go like, wait, what? Hold on, what? This is the particle system. So this is the stack of processing that happens to a particle system. It has to do with emitting objects, how long those objects will live. Here you can see arc count, layer count, all these other things. This is the system that is being talked to through the blueprint. I have all these user parameters in here and stuff like that I can adjust. Cone. I have a user parameter I made here called layer cone offset. That parameter right now is set to 10. If I set it to 1, everything changes. Because what's happening here is I have a whole lot, I think I have the layer count is set to 30. Layer offset right here. Layer offset right now is set to 0. So if I set it to 10 as well, now all of a sudden the thing is going out in space. So what I'm doing is these are being progressively altered with each time I go through it. So basically I have one value of 10 for its position in space. The first one, the index of execution is 0, right? It's the first one. So 0 times 10 is going to be nothing. So it's not going to move anywhere in x. The next one's going to be 1. 1 times 10 is going to move it 1. The next one's going to be 2. 2 times 10 is 20, etc., and so forth. And so this is really all that's happening is I am looping over all of the objects here, and I'm incrementing the value with each lap. The other one I had here was cone, so I can take cone down and I can set it to 0, and now we get a straight 2, right? So it's just, I have this one that I'm doing that is, making it spread out because it's affecting a different variable, and then the other one that is the x offset, I can make, I just made it, it dragged and it went, but now it's 25. Right? So you get the idea of the progressive escalation of the value based upon the idea of having a bunch of things. Think of this as an array. Every layer is a member in the array, and with each one, there's an index that is part of, like, I'm going to go look at you, and we can use that to multiply this value and create a progressive offset. So now if I can actually go inside of my blueprint and look directly at the Niagara system and these variables that are built inside of it. So here we're seeing the same things that we saw before, and here's my generated palette based upon the fact that there are 30 or 29, which is 30 when you start on 0. So there's 30 layers to this. And so that means I generate 30 colors off of the seed color, and I apply these to it. And I actually have more colors in that because I had a different set of seeds. But anyway, you see all those, and then we go down here, and now here's another array. This array is the index that each row should use into that color palette. So the first one, I'll go down to the end here, and I'll start changing these to 0. 0. So this is the end one. See how it's 0, 0, 0, right? So basically what I'm doing here is I'm changing the data in the array and telling it where it's going to look in the palette for each one. I also have mesh. So in the Dynamondala, there is actually an array. And this array right here is the mesh pieces that can be in the mandala. All right, so these are meshes in an array. In my code then, every row has an index for the mesh that they will choose. So if I change this to 2, now we get a different mesh there. If I change it to 3, so again, this is just our or look up into an array, right? And so we've got the last 3 rows with different meshes, okay? So now, if I go, this is something I'm really excited about, which is that I can actually do this kind of composition in the editor now. It used to be only that I could do it while the program was running. This is the beginning of me really being able to do more kind of bespoke creation of what I'm doing. But seeing that this has these different ones at the end here, so by using the in-editor mesh index, it'll use whatever I've set up. BCR is 3. I'm also just going to move this guy back so he's easier to observe in what we need right now. I'll just pull it back far enough that we can see the whole thing. Well, totally what I meant to happen. Not. Okay, so now we see that we saw what we were getting in there before, where it's almost all one value, but then there's this other one that's different. And you can see what a work in progress my entire system is here by how awkward it is to operate, but we'll get there. Anyway, so now we're seeing all of the meshes change, right? And yet it's still different on the ends from the other ones. So what's happening is that I have a button here. It is, I believe, I'm not sure what number it is. I'll tell you in a second. Ultimately, this is select on int, which means it's using the CC number of the incoming value, which is identified as a way to filter which of these events will fire, so that not every single one will fire, only the specific one that we are looking to adjust. So in the case of what we were just doing, we have this one, control number 41, fires the event step mesh index all. If I right click on this and I say find references, it will help me figure out where the hell the part that I'm actually calling is. It gives me these steps here. So if I go step index mesh, I'm using it again in another spot. So here, this is the actual event that I created. This is the array that we saw earlier called layer mesh indexes. And this is a for each loop. For each object, it is going to find it, get that value. This is a special node with a double like that. It means it's going to increment this integer by 1 and then set that value. So we don't have to have a separate node that says get and set and stuff like this. So basically, it's going over the entire array. It's grabbing each number, incrementing it by 1. It's also doing something here called a modulo, which is a way of making a list loop back over. In fact, what it is a divide that only returns the remainder. So if you are dividing 8 by 9, you get 1, because it goes in 1, remainder 1. It goes in 1, 8 goes into 9 one time and leaves you 1. So the result will be 1. So if you have a list of 8 things, then 9 will give you 1, wrap back around. 10 will give you 2, etc. and so forth. So modulo is a really cool thing to know about. Took me a while to get my head around it, but it's really good for whenever you're trying to iterate through things and you want to wrap like that. I use it a lot. So what I'm doing is I am going through, getting the array element, incrementing it by 1, checking to see if it wraps over the total list of available meshes. Because if I increment them by 1 and increment them by 1 and we start to go beyond the number of meshes that are available, I'll just get blank space. Some of which actually does happen in the Dynamandala, and everybody thought it was a feature. And so anyway, it'll wrap it, and then it will set that array element back again. Notice the array index coming off of here is telling us what lap of the loop we're on. And therefore, it's going to get 0, increment it by 1, it's going to set 0. Then it's going to get 2, then it's going to get 3, until it's gone through all of them. When it is done going through all of them, it has an event that fires that's called completed. When that happens, now I've got a reference to my iNiagara system. I know that there is a layer mesh indexes array in that Niagara system. And so now that I have taken this layer mesh index array that I've got in the blueprint, incremented all the values, and then I send it to the particle system responds by showing itself with the newly updated array. Therein is most of how the Dynamandala works. An event happens of input. It gets filtered to the particular event that you want to control. I actually have this data table. A data table is basically a spreadsheet. Okay? So these are all my default parameters for the basic mandala, right? I can change things in here and make other basic defaults. But I actually, when I start this thing up, another really important part is that I go through here, I open up the data table, I loop over the contents of the data table and put each row into an array. That array is now in my object, and it is indexed by the same numbers that I use to identify the controls on here. So that when a message comes through, it goes and it looks at that array and it finds the corresponding number, and that's the value that it manipulates. Saves that value, and then goes and finds the corresponding event that is driven by that number, and updates and does the logic that ends up with that being sent to the Dynamondala and showing up in the visual feedback that we see. So that whole idea of looping over the array, stepping each mesh index, and then writing again, that's why I went there, because loops could be a little bit challenging otherwise. Going back to our model that we were doing, instead of showing you how I'm going to build it, I'll show you the finished result just so we can see it, okay?
Yeah.
We have been building a blueprint that has input values to it, keys that we can hit, and it hops up and it drops down, and when it drops down, it randomizes its color, okay? So now, that blueprint object we can place in the world, and it'll work just fine. We can actually make a blueprint that spawns blueprints. So what we're going to do is we're going to take that one versatile functional object we made that will spring up in the air and come back down and randomize its stuff, and we're going to place a bunch of those in the world, and we're going to randomize their values. So we could do that by hand, which we've been doing. We've had 3 or 4 copies out there and stuff like that. Or we can script the manual operation of the program and generate a whole bunch of blueprints. So I said I'm not going to show you how to build it, but this is where the construction script really comes. I'm not going to show you how to build it, but I'll walk you through it. This is where the construction script really comes in handy. So here we have this one blueprint that has many objects in it. And it has some important user-exposed variables. And those user-exposed variables are mesh count. So see, I can make more or less of these. And I have also cube step, which has to do with how close or far apart they are. I'm going to put this many of them in there, let's say. And I have min and max, which is the jumping range. I'll just leave it at 1 and 100. So now, okay, so there they are. And now I run it. And if I hit F, they jump up, and when they drop down, they all randomize colors. And then if I hit it again, now they start doing, woohoo, yay, all right, good, okay, it's super great, far out, yeah! Creative coding. So these cubes that we're seeing here that are gray are just there as a visual reference so that we know how many we're going to have, right? As an editor working in this, we might go and set these variables and, okay, run it, how's it look? No, I don't run it, you know. But this way, we have user interface built into our object that makes it more effective as a tool working at what we're doing. So let's look at this all in a little bit more clarity. So that means that in the construction script, we're doing what we did before. So first of all, we have this representation, which is this, it's a static mesh. I'm using a cube. This instant static mesh is a way to be able to put multiple copies of something into a world. Don't ask me anymore. But basically what I'm doing is I'm using a for loop. Now before we saw a for each loop when we were changing the index of all of the layers in the mandala, because it's in an array, and if you've got an array, you can use a for each loop because it knows, and it's specifically meant to take values from an array. This is a for loop There's another kind of loop that's very important, which is it means it's going to do this as many times as you tell it to. So I have a variable coming into this, which is an integer, because there's no, you don't need 3.5 cubes, I need 3 or I need 4. And so a whole number works just fine. And this mesh count is saying what is the last index of the for loop. The first is 0, so basically however many times I put in here is how many things it's going to do. So when I go in here and I adjust mesh count, you see this is going to do it 4 times. This is going to do it that, etc., right? So we are controlling the number of times that we add an instance, which is a cube, by controlling this for loop. It's going to do this for us X number of times. In this case, we also have this value called cube step, which is by default 200. Every lap of the loop has an index. By taking index and multiplying it by cube step, I am able to figure out the position to offset them in the y-axis to make a row. The first one won't move at all because the index will be 0. The next one will move 200. The one after that will move 400, will move 600, etc., and so forth. But since I made this a variable, I can actually go in here and change that number and have them right on top of each other, have them way spread out, or whatever. So this is visual feedback. These are just, this is just an integer. It's that it's being used to control, or no, excuse me, this is just a float, this is a cube step. It's being used to control the spacing of the objects. This is just an integer. It's being used to control the number of times that this loop will happen. These are not any different from any other time we've used an integer or a float. They've just been applied differently. So the principle of what these variables are doesn't change. The application does, and that's what I'm trying to say about the idea out of the simplicity we can get complex behavior. Okay, so then over here, I use the same numbers. Mesh count, same variables. This is in the event graph. This is what's going to happen when I run the program, because see, it says on event begin play. But because in the construction script I set these variables based upon my visual feedback, I can now go into the event graph and use them to make a for loop and to use a cube space, but to spawn blueprints into the world. So the command in the construction script is to add another piece of mesh for my visual reference. The command in the event graph is to spawn a blueprint for each one of those spots. These blueprints we spawn are objects that we built that can take our input and will jump up in the air and will randomize their colors when they come down. Each one has its own, each instance has its own version of the functionality we made when we wrote the original jumping cube object. But now we're copying a bunch of them out, and as we copy them out, I've also got a min and a max number going in to set the cube's range. And that's just a beginning bracket, right? So if I go over here and I set the high number to 2,000, well, let's do 200, why not? And now we play it. So they're going to jump, but they're jumping randomly within that range. So they're just doing what they've always known how to do. We've just used another blueprint as a tool to help us create them in the world. So that again is complexity from simplicity. There's really no difference between the blueprint that is spawning all these other blueprints into the world or the individual blueprints themselves. They're objects. But it's the clever capitulation of the stage that you use them in that allows us to end up with this result. Okay, I know we're almost done. So I could show you more about what's happening in the mandala and stuff. If anybody wants to talk more about it after we're done, that's cool. But we've seen all these things: flow control, looping, flow control, conditionals. We didn't really get into debugging. We saw a little bit of the wires, going across there. There's an extensive ability to add breakpoints. Comments are really important. We can trace exactly what's going on with the code on a moment-by-moment basis. But I'll go back to the opening of this because I think it was pretty right, which is these are the core elements of programming. This is one of the things I really wanted to get to for everybody, was to try and look at everything that happens in the Dyna mandala as an event, a variable, a loop, a flow control, a function. This is really all the tools that exist. There are additional types of data that are used and things like that we could get into, but really, without being too simplistic, this is all that exists. And therefore, from these simple, basic parts, obviously, we can make more complex things. And ideally, the fact of this simplicity makes the whole process of being willing to jump into and try coding a little less intimidating. We've talked about what programming is. It's talking to a machine. So you've got to be very, very specific, much more than you would be talking to yourself, probably. Designing algorithms for everything to happen. The biggest one is that actors, objects, blueprints are all the same thing. A class is the instruction for setting up one of these things. That's one of the areas that was the biggest clearance of confusion for me that started to make the world open up as I was going. We talked about Unreal. I don't have a great closing slide. There you go. Whatever. Creative coding with game engines. We're done. I don't know. Does anybody? Thank you. Does anybody have any questions or anything like that? Yes, yes.